Good morning, everybody. This is Peter Ryan, and welcome to this next edition here of our Auto Call Fire Detection Academy webcast series. We are very honored and privileged today to have Roger Reiswig with us. I know most of you already probably know Roger, but Roger is our fellow and VP of Industry Relations here at Fire Protection Products and Johnson Controls. And Roger sits on numerous committees, NFPA, AFAA, the list goes on and on. I don't think we have time to go through all the qualifications. And Roger is also the tallest person that I know personally. So that's always an exciting thing, especially for someone from my stature. Today, we wanted to share with you some updates on carbon monoxide. This is something that, as I travel with Roger and talk with different folks around the world, there's always a lot of real, I would say, confusion, curiosity, questions about carbon monoxide. We find a lot of especially misconceptions about what it is, how it behaves in a structure, and exactly what the code says about how you protect a structure from carbon monoxide, especially where the sensors get placed, what the dispersion is, et cetera, et cetera. So we thought this was a really relevant topic and a really important topic for us to cover, to clear up those, and then to share with you exactly how all this goes together to protect things like parking structures, dorms, residential facilities, et cetera. In this era of COVID, I know we're all getting extremely familiar with webcast interfaces. So, just a quick one here on Teams, on Microsoft Teams, everybody's mic is open. So please mute your mics to make sure that there's no background noise and everybody can hear. And also, what we want to do is we want to hold questions till the end of the session so that Roger and we can address them rather at the end. For the questions, you can use the chat window and type in your chat questions at any time during the process, and we'll go through those and again try to address them at the end. And also, if you get to the end and we have a question that you want to ask verbally or to add more explanation to, you can use the raise your hand icon, and we'll know who did it, and we'll certainly be able to call on you and open your mic. So with that, I want to pass it on over to Roger here and kick off the presentation. Roger?
Well, thanks, Peter. I appreciate it, and thanks for your support and all the work that you do, and Anne-Marie and the rest of the team supporting us. So as we were talking about the series, as Peter had said, carbon monoxide comes up a lot in what we're doing today. There's a lot of questions about it. Peter and I, we get phone calls a lot about placement and what's code saying. So, excuse me, as part of that, we thought, well, let's go ahead and just dive in and let's do a little bit of a background about carbon monoxide and what it is, how it's implemented. And for those that maybe have heard me speak in the past, I'm kind of a why guy, meaning let's talk a little bit about how we got to where we are, why are we doing what we're doing, or where are things coming from, rather than just say, this is what the code says, this is how you do it, and move on. So I like to do more education as we go through it. So as we jump in, I want to talk a little bit where things start first in our codes. Remember, building codes tell us when to do something, building standards tell us how to do something, and then the listing standards tell us what products we can utilize. So it all starts with the codes. So with that, when we go into the International Code Council, there was a lot of changes that occurred in the 2018 edition of the code for International Building Code, International Fire Code. And for those that don't know, the IFC is basically the same as the IBC. The building code has pretty much a holistic view about everything that you would need for a building when it comes to the code aspect for life safety. But there are some facilities or jurisdictions around the globe that don't really need a building code. They already have one, so they ask for a fire code only. So that's kind of why they're separated. But they're identical in almost identical in what the fire code has, the building code has in it as well. So if you hear those two terms being thrown around, that's what's going on. So as we jump into it, one of the first things that has occurred, it needed to be change the verbiage. And it really is all about the words in what we do. We have carbon monoxide alarms and carbon monoxide detectors. And people use the words interchangeably, and they really shouldn't. especially us as leaders. And I'm saying you're a leader because you're trying to advance your own education by attending webinars like this. But we as leaders should be using the right type of language as we're describing things. Like, we don't talk about smoke detectors and smoke alarms the same way. Same with carbon monoxide. So a carbon monoxide alarm, similar to a smoke alarm, it's a device that has its power supply, carbon monoxide detector, and notification appliance in one package, kind of a standalone thing. Where a carbon monoxide detector is a device that needs to sample or look at the atmosphere, decides what's going on, and then sends that data back to a control unit who then decide what it needs to do. So, we really need to use the right languages for things. So much so that the I code was calling everything detectors, and in 2018 made the distinction like they should have. So in section 915.1.1, and again, same section if you're in the I code, whether it's the IFC or the IBC. So where these are required. So some of the changes or things that have occurred is more changes to enhance occupant safety, providing notification to a responsible party, if you will, of a malfunctioning fuel burning appliance or something like that. And that's where these come into play, right? If we back up for a second, we need carbon monoxide detection to notify us when there is some type of thing going on with a fossil fuel burning appliance, whether it be an HVAC, a water heater, could be a vehicle if we have an attached garage, can be a fireplace if the fireplace is burning wood, fossil fuel burning or natural burning materials. A byproduct of incomplete burning is carbon monoxide. So in section 915.1.1 of this code, it allows either carbon monoxide alarms or detectors to be installed in new Group I and Group R occupancies by using the term detection to cover both alarms and detectors. There are two problems with installing a CO alarm in locations outside of a dwelling unit. First, the UL product standard stipulates CO alarms are only intended to be installed in dwelling and sleeping units. And then second, no one will hear the audible alarm signal because the locations are in unoccupied areas of the building behind a locked door, such as a furnace or boiler room, etc. But a CO detector will send an alarm signal back to the fire alarm control unit and then in turn to a supervising station, notification appliances, etc. So for 2018 code, only CO detectors are allowed in locations outside of dwelling units. And this is where I say it starts to, really need to understand the terminology as we're going forward on how they're saying, or how they're talking about detectors as opposed to alarms. So they're not the same. In 915.1.4, it covers where the fuel burning appliance is installed in a building, is located outside of the dwelling unit, sleeping unit, or classroom, which is in a remote, unoccupied area of the building. So the term detection was replaced with detector. And so it means only detectors are allowed in these rooms containing these fuel burning appliances. And I guess I know these are kind of maybe a mundane thing, but it's important because we just can't go out, run down to a local Home Depot, Lowe's, grab a cheap carbon monoxide device, throw it up on the ceiling and think that we're in compliance with the code, because that really is not the intent of what we're doing. In garages, people kind of forget about carbon monoxide coming from vehicles. Vehicle either running for a long time, maybe idling, can build up CO over time, and we're going to discuss that later on about how concentration levels affect us. But it could be a vehicle that's malfunctioning. Somebody pulls into a garage and lets it run. So when we look at these attached private garages, the term detection again was replaced with detector, which means only CO detectors are allowed in these approved locations within private garages and dwelling units. Now when we get into the Group E occupancy, Group E is very educational, and educational occupancy is typically K through 12, kindergarten through 12. It is not, and there's a lot of confusion about this, educational occupancy is not a college, university level occupancy group. Those occupancy groups where the dormitories are going to be your Group Rs, residential occupancies, And then where the classrooms and the labs and all of that is, they're not Group E, they're Group B, B for business. And as a parent who's had two daughters just complete college very recently, and believe me, it's a business when you go to these universities and colleges. You spend some money there. So Group E is for K through 12. And detectors can be installed because installing a CO alarm in a school are not listed for that purpose. Again, we need to use carbon monoxide detectors tied to a control unit, because then I can send the signal off-site to a supervising station and or to our notification appliances throughout the building or in certain areas to alert people. So if I would just put a single station alarm, carbon monoxide alarm, in a boiler room or some other area that had a fuel burning appliance and it went off, nobody would ever hear it. So they're not permitted to be installed in these locations. Now, if we go into 402.6, carbon monoxide alarms in existing portions of a building. So now we're in the International Existing Building Code, the IEBC. So if we look at this, the scope of this code covers existing buildings undergoing additions, alterations, change of occupancy, and provides that guidance. In section 402, it covers existing buildings undergoing these additions, and CO detection is now required in accordance with the fire and residential code. So we should mention that the residential code covers detached 1- and 2-family dwellings and townhomes not more than 3 stories. The fire code covers all other residential occupancies, such as a hotel, apartment, dormitory, something like that. So as you can see, there are exceptions which were taken from the residential code. The exception stipulates that CO detection is not required when work involves replacing roofing, siding, windows, doors, etc., or decks. This change does provide consistency with the IFC, the International Residential Code, IRC, and the IEBC with regards to the installation of CO alarms and detectors. So again, you're starting to see them correlate. With all of the I codes, unlike NFPA, all of the I codes are in the same cycle. So when a new cycle comes out every 3 years, a cycle is 3 years for the codes typically. Sometimes they're a little bit different. But so in 2018, we had the full suite of the I codes come out, and then we're going to have another full suite come out in 2021. But by doing that for the I codes, it's very easy to make sure that they have synergy from one code to the other and how they correlate with one another. Now in section 403.11, we have carbon monoxide alarms, and again, we're in the IEBC here, and it covers buildings that are undergoing alterations again, and CO detection is now required in accordance with the fire code in assisted living facilities, hospitals, nursing homes, daycare buildings, and residential occupancies. You know, CO detection is really starting to become more and more of an issue for us. It's been an issue for many, many years, but even more so today, where we're having appliances that are much more fuel efficient. However, when they're apt to break down, they tend to leak more carbon monoxide into the atmosphere. Also, our buildings that we have today are tighter, and we don't have as much fresh air exchanges into a facility as buildings of days gone by. In 704.3, here we have the Property Maintenance Code, the IPMC. In the past, there were no requirements in this code for the maintenance of CO alarms or detection systems. So the changes require now that CO alarms and detectors to be maintained in accordance with NFPA 720. 720, it's not a typo there for those that don't know. 720 is the standard for carbon monoxide alarms and carbon monoxide detection systems. Now, 2015 was the last edition that NFPA 720 has created. There has now been a move to disband the NFPA 720 Technical Committee and pull everything into NFPA 72. So the scope was changed a little bit for 72, and we now have everything for carbon monoxide within 72 for 2019 going forward. But you have to look at the date on this. So the 2018 edition of the ICC references earlier editions. So they reference the 2015 edition of 720, the 2016 edition of 72, etc. So the document is still available to be purchased, is still used. So just because it's no longer being updated doesn't mean it's been totally pulled out of the industry. So it's still there for that. And also, there's now a requirement for those that might not know for an end-of-life signal to be installed or required for our carbon monoxide alarms. And I'll just take a second to talk about this. With smoke alarms, there's been a requirement for decades that they be replaced every 10 years. And it's 10 years from the date of manufacture. And that was a study that was done by NIST, who had said, and really haven't updated this for many years now, but at the time they said the electronics, they were mainly focusing on the capacitors back in the day, that an average device could last about 10 years. And that's where the requirements came in for smoke alarms to be replaced every 10 years. With smoke detectors, again, another side note, smoke detectors, they can be in place and can remain in place as long as the device meets the sensitivity requirements and functionally tests properly in the annual inspections. So there is no requirement of when to replace a detector, just as long as it passes the test, unlike alarms. Now, carbon monoxide alarms, just by their nature of how they function, they have a finite life expectancy based on how the detector functions. There's some materials that are in there, and it varies by manufacturer, and how there's some gases that are put off, and then that gas is then used to compare to the atmosphere that it's around, and then the deviation gives us a report of carbon monoxide. But not to go into a whole lot more than that, but that material that's in there has a finite life expectancy. Some are 5 years, 7 years, some are 10 years. It depends upon the manufacturer. So what UL is now requiring is that the devices need to have an end-of-life signal, meaning when it meets that 5-year, 7-year, whatever you as a manufacturer have determined, your alarm needs to provide an end-of-life signal. Now, the same thing is also occurring now on our smoke alarms. So when you go to Home Depot, Lowe's, Walmart, and you buy a smoke alarm off the shelf, it's got a date on it, a month and a year. At the end of the 10 years, the smoke alarm is going to give you an end-of-life signal, and the carbon monoxide is going to give you an end-of-life signal too, based on the manufacturer's time frame. So you can't say all carbon monoxide devices last 5 years, 7 years, 10 years. It all depends upon the manufacturer. But I'm also saying all of this because you're probably starting to see, because this has been in effect now for probably close to a decade. So now we're starting to see the devices that have been out there for 7 years, 10 years, have their end-of-life signals activate. And we're getting phone calls from people, and we want to help the general public too. And they'll say, hey, my smoke alarm keeps beeping, and I've replaced the battery. What's going on? Well, pull it down and look on the back and see what the date is. Okay, they gave you the date, and it's like, okay, it's 10 years. It's not beeping for low battery. It's giving you that chirp for end of life. So anyway, if you start to hear that and they've replaced the batteries and they're still saying they're getting it, ask them to check the date. So now let's jump into interconnectivity here in our in 315.5 in the residential code. So this code change covers detached 1- and 2-family dwellings and townhomes not more than 3 stories. Again, we're in the residential code. This change seeked out to enhance the safety of the residents by requiring CO alarms to be interconnected, very much how we've done with smoke alarms over the years. When more than one carbon monoxide device is installed in the dwelling unit, they're now required to be interconnected. Interconnection, provides that notification, to the occupants. If there's one in the basement and you live on the, or your bedroom is on the 2nd floor, will you hear an alarm in the basement? Well, now with them being interconnected, you're going to hear that. So when carbon monoxide is detected, it activates the tandem connection to all the devices. The residential codes required smoke alarms to be interconnected within dwelling units for several decades now, and the ICC membership decided that it was time to do the same thing for carbon monoxide alarms. So now let's jump over to the other side, NFPA. And again, for those that don't know, NFPA, the National Fire Protection Association, they're in some respects a competitor to the I-codes. The International Code Council is a separate division or separate entity. They make building codes. NFPA makes building codes. Some are used in certain places. Some places use both, depending upon where you are. But there's still confusion as I go around about people saying, well, how does NFPA and the I-codes work together or not work together? Well, they're in many respects, they're competition to one another. However, the I code doesn't write standards, so they'll reference back to NFPA for their standards, like NFPA 13 for sprinklers and 10 for extinguishers and so forth. So the building code for NFPA is 101, the life safety code. And coincidentally, you have the 2018 edition as well. And in 2018, you start to see some similar verbiage, some similar actions that took place. Although they are separate entities, NFPA and the I codes, a lot of us, and I'll say us, like me, Peter Ryan, and a few others, we work on these codes, and we go to the I code meetings and we go to the NFPA meetings. And so that's why you start to see some of the same languages, because it's the same people providing the language to the code people on what needs to be changed or how that should happen. So there were a lot of changes that occurred in 2018. We're focusing just on carbon monoxide here with 101. So the first change in Chapter 14, Section 3441, that only carbon monoxide detectors are permitted to be installed in new K through 12 or educational occupancy schools, and they deleted the reference to CO alarms. Again, it's all about terminology. And as mentioned previously, the UL product standard stipulates CO alarms are only intended to be installed in dwelling units and sleeping units, not in open area, other areas of a facility. And in Section 14.3.4.4.2 is new, and it requires CO detectors to automatically send the alarm signal to an approved on-site or an off-site location in accordance with 720. So now we're looking for these devices to be supervised as far as sending a signal to somebody that may be at a desk 24 hours a day, whether it's like an operator station or security station, or send it off to an off-premises location, kind of like we do with fire alarm, to a supervising station. CO detection outside of hotels and dormitory sleeping rooms. We have these next series of changes for fuel burning appliances in a building that has locations outside of dwelling units and sleeping units. So for hotels, dormitories, Section 28 or Chapter 28, Section 3474 was revised so that only detectors will be allowed in locations where fuel burning appliances are used in a remote and unoccupied area of the building, such as a furnace, boiler room, or what have you. And the code will continue to permit CO alarms to be installed in accordance with their UL 2034 listing, which is in dwelling units only. So Section 28, Chapter 28, Section 3475 requires that CO detectors to automatically send the alarm signal to an approved on-site or off-site location. So again, if we're in a hotel, for example, the approved location could be the front desk. We have a fire alarm control unit there, as we commonly do, and now our carbon monoxide devices could send a signal there. As a note, we'll talk more about it later, but just to plant the seed now, a carbon monoxide detector must show up on the fire alarm control unit as a carbon monoxide event. It is not a supervisory, it is not a general fire alarm. It must show that it's a carbon monoxide detector, which may be an issue if we're changing out or modifying an existing hotel that maybe has an older fire alarm system that only does alarm, trouble, and supervisory. There needs to be a way for us to monitor that additional state. Chapter 30, Section 3464, for apartment buildings, we now have revisions that only carbon monoxide, again, detectors will be allowed in locations where fuel burning appliances are located outside of dwelling units. Again, getting rid of the alarms in these locations. The code will, again, still continue to allow UL 2034 devices in the bedrooms themselves, but not in these remote locations. And board and care facilities, same thing. They're requiring detectors now and gotten rid of the verbiage for carbon monoxide alarms. When we get into larger board and care facilities, it's kind of the same thing. Guess we should have said it earlier. Don't worry about writing all of these down. I think Anne Marie is going to make these slides available to us as a PDF you'll be able to download and have this material. So a lot of this in here, I might be going through it a little bit quickly for you just to write everything down, but you're going to have this material. So again, changing it from alarms to detectors in these facilities. And Chapter 32, 33494 continues in the building board and care facilities. For sleeping areas, carbon monoxide alarms or detectors are required to be installed in the following non-sleeping locations. First, we have to have them on the ceiling in the rooms containing a permanently installed fuel burning appliance. Second is for the detector to be centrally located within the occupiable spaces and served by the first supply air register from a fuel burning appliance HVAC. So we're going to go into more of this as we get into NFPA 720 and 72 later on. And detection is also in assembly occupancies. A lot of these occupancies have added in carbon monoxide detection because there have been cases where we've had boilers, HVAC, some type of a fuel burning appliance that malfunctioned and caused a group of people to become ill, and in some cases, some people pass away because of their poisoning of these gases. So this, when I look at codes and standards and why they change, I usually say it's because of one of three things. It's either because something happened in our industry. We found out that large amounts of people either died or are being succumbed to some type of injury. The second is going to be research. Research has proved out a better way, for things to happen. And then the last one is going to be technology. There's a new way for us to do something that we weren't able to do before, and technology allows things to change. And usually you can always trace back to one of the three things on why a code or standard changed within our industry. So now we jump over into NFPA 72, the 2019 edition. So a lot of what you're going to see here is all pulled out directly from NFPA 720. When we worked on this, I say we, I was very involved with 72's 2019 edition and pulling this in. There were several task groups that were developed, and everything that was in 720 had to be pulled into 72, which meant let's put it into the fundamentals. How should we supervise this? How should we battery back it up? Chapter 17 for initiating devices, Chapter 14 for how do we test it, Chapter 18 for how do the notification appliances work, and just on and on and on. So it really was a huge change to add all of this into 720. So now let me go through this. 720 now, again, is no longer being updated. It stopped in 2015. But everything has been pulled into 72 for 2019. So we haven't really lost anything. And the scope of 72 was changed intentionally back in 2010, and also the title, to help 72 take on more of what it was doing, where we were bringing in mass notification systems, bidirectional repeater antenna systems for firefighter radio, first responder radio systems, using elevators to evacuate occupants from the elevator code and how that needed to be incorporated into 72. So with all of that being added in, the scope was modified as well as the title to National Fire Alarm and Signaling Code. So now in 17.12, we get into the, again, Chapter 17, initiating devices. We get into where or how these devices are to function and where to locate these devices. So where required by other governing laws, codes, or standards. Again, 72 is an installation standard telling you how to do things, not when to do things. So people still ask us today, they'll give us a call and say, hey, where in 72 does it tell me I need a fire alarm? Where in 72 does it tell me I need carbon monoxide? Well, in the document, you're going to see over and over where required by other laws, codes, or standards. So when somebody else says 101, the building codes, or what have you, this is what you do. So 72, just like 720, says to put one on the ceiling in the same room as the permanently installed fuel burning appliance, centrally located on every habitable level and in every HVAC zone of the building, and outside of each separate dwelling unit, guest room, guest suite, sleeping area within 21 feet of any door to a sleeping area, and in other locations that might be required by an AHJ, and if you're doing some kind of a performance-based design. So let's back up. So we say to put them on the ceiling in the same room as the permanently installed fuel burning appliance. There's a lot of discrepancies out there about should they go on the wall, should they go on the floor, should they go on the ceiling. So NFPA has something called the Fire Protection Research Foundation, the FPRF. They're a wing, a division of NFPA, and the FPRF does research to substantiate changes to the code, whether it's sprinklers, glazing on windows, fire apparatus. They pretty much do it all. They don't actually do a lot of the research themselves, but they're kind of the governing body to oversee and hire various research bodies around the globe to do the research for them. They do some themselves, but not a lot. So research has found that the specific gravity, the weight of carbon monoxide is almost identical to our atmosphere, to air. It mixes freely, quickly, and disseminates itself throughout the atmosphere very, very fast. It doesn't fall to the ground like some people think. It doesn't rise to the ceiling like some people think. So you can pretty much put a detector almost anywhere and it would detect carbon monoxide in an area. So now we get into life safety and we say, okay, we're now telling you to put it on the ceiling above the fuel burning appliance. Why are you telling me to put it on the ceiling? You just said that it mixes freely with air. The answer is because it's a fuel burning appliance. When we heat up air, where does the warm air go? Warm air rises. The thought is, if warm air is going to rise, it's going to take that CO with it first, and let's give you the quickest way that we can detect that CO by requiring the device to be on the ceiling. That's the only reason that it's put on the ceiling in that fuel burning appliance, where that fuel burning appliance is. So that's why we say to put it up there. Next is centrally located on every habitable level and in every HVAC zone. As carbon monoxide mixes freely, quickly, easily with air, it's going to go everywhere. So the thought is you don't need to have a carbon monoxide scattered like you do smoke detectors throughout a facility. You just need one within every HVAC zone because it's going to detect it pretty quickly. There is no spacing requirements for carbon monoxide. That study has never taken place. NFPA has done some exhaustive research. Nobody has ever done a study of how you space carbon monoxide devices. So if anybody's telling you that CO is spaced 50 feet apart, 30 feet apart, 100 feet apart, there is no such thing. And you won't find anything like that in 72 or NFPA 720 or any of the building codes. Now, we do say for the third one here, outside of each separate dwelling unit, guest room, guest suite, within 21 feet of any door to a sleeping room. So there is an acknowledgement that we want to have a carbon monoxide device in the room, kind of like what we do, or in the floor, kind of like what we do with smoke alarms. But again, you don't need to put them everywhere, but we do want to have a little bit of extra protection by all of the sleeping rooms. So the thought is, where does the 21 feet come from? And I think it's important to understand why things and where they come from and how they were put in there. Where does 21 feet come from? For those of you that have done fire alarm for a while and smoke detector spacing, the 21 feet number should be very familiar to you because that's what we require for smoke detectors. The furthest point, hypotenuse of the triangle, when you're laying out a device, the furthest away that it can be is 21 feet to a corner, a door if you're going elevator lobbies, etc. The thought is, again, we're talking about detectors, pretty much in the life safety commercial world, you're going to have a carbon monoxide device that's a companion to a smoke detector. A lot of manufacturers have just built both together. And you only have to put one device on the wall, program at one time, maintain one device, etc. And that's what you see there to the left. That's a Johnson Controls smoke detector with a heat detector and a carbon monoxide. The carbon monoxide is the little round disc there off to the side on the base. So that's where the 21 feet comes from. And then other locations that might be required by the AHJ or a performance-based design. So then we say the detectors need to meet the following requirements. They have to be listed. They got to be listed to UL 2075, and that's for our detectors, and 2034, and that's for alarms. Now, there's two different listings because there's two different functionalities of how these devices need to operate, right? So if I take a carbon monoxide detector to UL, it doesn't have a power supply built in it. It doesn't have a notification appliance built in it. So it needs to have a different listing to go after. The performance requirements of how it detects carbon monoxide is identical in 2075 and 2034. So, and for many manufacturers like Johnson Controls, we have said, well, gee, if you're going to do a hotel, for example, and you got to put in carbon monoxide devices, why don't you put in one device that can do both? Because our devices are listed as both multi-criteria and multi-sensor, meaning each sensor can work independently, carbon monoxide, smoke, and heat, or they can work together. We can correlate them, where I need a little bit of CO, a little bit of smoke, and a little bit of heat, and go into alarm. So we do both. When we took our smoke detector to get listed, it's listed to both UL 268 and UL 217. It's listed as a smoke alarm and a smoke detector. Obviously, it's a smoke alarm only when you use a sounder base, but we got both listings. We did the same thing when we got our carbon monoxide devices listed. They are listed, if you use a sounder base, it can be listed as a UL 2034 and just as a detector as 2075. So we got you covered at Johnson Controls on whatever the listing is, our devices meet it. So let's talk about carbon monoxide for a second. How does it affect the human body? And it's different than smoke. How the devices function is different than smoke. When a lot of this came from OSHA, Occupational Safety Health Administration, did some studies years ago where people were working in certain areas and they were saying, okay, how much exposure could a person have and still work in an area? And that's where the 8 hours comes from. So during a normal work day, how much of a concentration of carbon monoxide could be in the atmosphere and it doesn't have any adverse effects to the human body? And so this is research that came out and said, well, you can have up to 50 parts per million and not have any adverse effects to the body for 8 hours. So then we look at concentration and time because it changes. What happens when I have higher concentration levels? So if I have 800 parts per million of carbon monoxide, within 45 minutes, you start to get headache, nauseous, dizziness, and within 2 hours, you're probably going to become unconscious. If you raise that to 1,000 parts per million, you're going to become unconscious in about an hour. 6,400 parts per million, you're going to have a headache, dizziness within 1 to 2 minutes, and then unconsciousness and close to death within 10 to 15 minutes. So what I want you to take away from this slide is carbon monoxide depends on the concentration level and the time. So kind of remember this as we move on. Now when I go to UL and I say, hey, UL, I want to get my carbon monoxide device, whether it's a detector or an alarm, I want it to get listed. This is how UL tests my device. They put my device in a room and they inject 30 parts per million into the room, and my device cannot go into alarm until after 30 days. I passed that test, they cleaned the room out, now they inject 70 parts per million. I have to go into alarm not before an hour, but not after 4 hours. So I got a window there now. So once I hit 70 parts per million, I have to wait for an hour and then go into alarm. Anywhere within that 1 to 4 hour window. I pass that, clean the room out, now re-inject 150 part per million, same thing. I have to go into alarm no sooner than 10 minutes, but no later than 50 minutes. Pass that test, clean the room out, inject 400 part per million, cannot go into alarm before 4 minutes and not after 15 minutes. So it's concentration and it's time. This is why you can't walk into a facility, have a carbon monoxide generator, pop it into the CO device, and stand there with it and say, hey, it's not going into alarm. It doesn't work like a smoke detector does. So how do you test carbon monoxide devices? Well, what UL has allowed us to do, and many of us manufacturers came around the table. I do a lot of work with NEMA, National Electrical Manufacturers Association. I actually chair the life safety section. And we being Gentex, System Sensor, Honeywell, Siemens, Simplex, we all worked, Autocall, we all worked with UL, and we said, look, there needs to be a way for us to test these devices. Customers aren't going to allow me to come in, inject 400 part per million of CO into their device, wait for at least 4 minutes, maybe 10 minutes for the device to go off. It's going to take me forever to test all the devices, and nobody wants this much concentration of carbon monoxide in their atmosphere. So UL allows us, this is different for anything else that we do, UL allows us to turn on a feature in our control units that disables this algorithm. So I know it sounds counterintuitive about everything else we do with fire alarm, but it's the only way that I can actually test the sensor with a minimum amount of carbon monoxide in a short period of time. So that's how we test them. We go in and we turn off, and everybody does it the same way, right? So this isn't something unique to Johnson Controls AutoCall. This is the same, whether you're Gentex, Hochiki, whoever you are, you're going to turn off this algorithm. So if you've heard about that or how people are testing it, that's how and that's why. I hope all of this makes sense. So, another point, I'm probably going to I'm running out of time here. Another point is, this is why carbon monoxide devices are different for life safety than they are for environmental use. And I'm just going to, real quickly, when you are starting to now see some of the building codes for environmental use, say, when you see 20 parts per million or 15 parts per million, turn on some exhaust fans. When you see 25 parts per million, alert somebody that maybe there's a car malfunction in the parking garage or what have you. And people are saying, well, I can just use my carbon monoxide device to make that happen. Well, look at the timings. I have to wait for 30 days before I can go into alarm at 30 parts per million. So Roger, what are you driving at? What I'm driving at is with Johnson Controls carbon monoxide sensor, I'm both a multi-criteria and a multi-sensor device, meaning you, through programming, can do both. I can make it work as a life safety device. In addition, I can write an equation that says in 20 parts per million of carbon monoxide, activate this relay. You don't jeopardize, violate any UL listing or anything like that, and it's in full conformance. But that's kind of the power you have with the equipment that you get from Johnson Controls. So now in Chapter 18, notification appliances, we now have a new audible signal that's now required. It's been required for a long time in NFPA 720, but now in 72, this is new. So the committee looked at this and said, okay, if we're going to do temporal 3, which basically means don't be where you are, doesn't necessarily mean evacuate any longer, but temporal 3 means be somewhere else, relocate, maybe evacuate, what have you. Well, carbon monoxide, I might not respond the same way. Maybe when a carbon monoxide signal goes off, I want to open up doors, open up windows, because my colleague might have fallen asleep at their computer desk. I want to go wake them up, make sure they're coherent and can get out of the building. So I'm going to respond differently. So what they said is, we need a different signal. So we have like a modified temporal 4 that's being created. And it's a much more staccato, very fast beep. With temporal 3, we have beep, beep, beep. With this temporal 4, with its 100 millisecond plus or minus 10%, on off cycle, it's more of a beep, 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 beep. So it's a audibly different type of signal that's being activated. And so in some systems, you need to buy an additional sync module or temporal 4 module to create that signal. Some fire alarm control units have it built in, but that's now required that the carbon monoxide needs to send a different type of signal. So not just show up on the control unit as carbon monoxide, but also show up audibly as a different device. So here's the phasing of it that you see out of 72. The signal needs to be synchronized within a notification zone on a protected premises. So this is the same, whatever you're doing. Speakers, horns, bells, the signal needs to be synchronized, not the type of signal. So nowhere in code does it say you can't use bells, horns, piezos all in the same facility. There's a big misconception about that. But what does have to happen is whatever the signal is that you're using, it's got to be synchronized. Because now I need to be able to hear, is it beep, 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 or is it beep, 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 beep? Or if it's speakers. So everything, what the code did is they backed up and they said, you know what? It doesn't matter what the signal is. If you're doing any kind of a signal, they need to be synchronized within a zone, which for us manufacturers, it's not that big of a deal to do. But if you have a notification zone where I have multiple signal circuits, you need to make sure that those are synchronized together. You know, if they're running off the same NAC panel or booster or what have you. So I got a couple of minutes here left. We're getting close to the top of the hour. Some of the frequently asked questions that I receive, and I thought I'd put this in here, is what about duct-mounted CO detectors? They cannot be used in lieu of spot-type detectors. There are some manufacturers out there who have started to spout this. Some people are saying, well, let's just put in a carbon monoxide detector in our ductwork and be done with it. Can't do that. The alarm thresholds that are used for CO have not been tested for this type of application. The air velocity has not been tested. The stratification of the CO, the performance of how this goes through, it's entirely different than smoke. And NFPA 101 and the International Fire Code, International Building Code require alarm thresholds for CO detectors to comply with UL 2075 and 2034. So if anybody is saying anything about duct-mounted carbon monoxide, if they want to do it, they can do it, but it's not allowed by the code to replace spot-type carbon monoxide devices. So what's the area of coverage for these alarms and detectors? There are no spacing requirements for carbon monoxide. Again, it's a big myth out there that people are running around saying it's 30 feet, it's 50 feet. And there is nothing out there. And some are getting that because they might be saying, well, I have smoke detectors and smoke detector has a carbon monoxide device with it, and a smoke detector is every 30 feet, so therefore carbon monoxides are every 30 feet, or carbon monoxide in the heat detector, and it's every 50 feet. That's not the case. It's only required in the certain areas in the HVAC zone, above the fuel burning appliance, one on every floor, but there are no spacing requirements for CO. Is building-wide occupant notification required? So, carbon monoxide signals are automatically transmitted to a constantly attended on-site or off-premises location that no building-wide notification is required. We saw that as we were going through the occupancy chapters in both the I code and NFPA 101. So if I'm sending the signals to a fire alarm control unit that somebody on site is always at, whether it be security, operator, nurse's station, whatever, then you don't need to send signals all throughout the facility, or if I'm sending the signals off-site. NFPA 720, again, 2015, or 72, 2019, intentionally gives this latitude. Selective occupant notification is permitted to be limited to the notification zone encompassing the area where the CO signal originated, kind of like how a carbon monoxide alarm functions. The integral sounder of a system-connected CO detector or a mini horn is usually sufficient enough and will also transmit a signal to a constantly attended or off-site location. And here to the right, if you look below the horn strobe, the device to the right, that's a combination device where it's got a heat detector on the top, smoke detector, carbon monoxide to the far right, and the speaker to the far left is a device for a sounder. So that's our answer to the UL listed as a smoke alarm, smoke detector, carbon monoxide alarm, carbon monoxide detector from Johnson Controls. So I know it's a lot of stuff I throw at you, and we're right about at 10 up, so we got a little bit of time left for questions. I hope this helps, gives you a better understanding, of CO. And Anne-Marie, Peter, if there's any questions, I'd be glad to take some questions.
There are no questions posed online, but if anybody has any, they could open their mic and pose one.
All right, well, you see my contact information there. I work closely with Peter, Ryan, and Anne-Marie a lot. If anybody has any questions, that I can help out with that's related to codes or applications, I pretty much don't get too much into the product side, although I have that background. But if it's code related, application related, AHJ related, please feel free to reach out. I'm a resource for you, and I'm no charge. Although if you ever do see me, a nice dinner or lunch once in a while is fine.
Roger.
But I'm here to help, like Peter and Anne-Marie are.
Question. Roger, this is Dave Henry. I got a quick question. You show the smoke heat CO sounder all as one unit, but from what you're telling me, you can also get by with the upper left unit that's a smoke heat CO and have all your sound come through the addressable notification device as individual appliance controls in place of that, correct?
Oh, that's a great spot on thing to bring up. So you're exactly right. With Johnson Controls, we now have addressable speakers, horns, and strobes. And just like you said, Dave, we can program them that if I see CO, I can activate that individual device. And we have low frequency also that's now required in these rooms to activate. Yeah, great point. So it doesn't have to be the sounder base. It could be our addressable AVs that can do that too. Speakers, horns, or strobes. Great point.
And that would give me the ability to take and have like a large suite, have multiple sensors and multiple notification all integrated without having to run any additional wiring in the building.
Exactly. And that gives us the tandem connection that's required in these large suites or condos or apartment complexes. And we wonder how we're going to make that happen. Johnson Controls has that solution to allow it to be addressable and program it. Yeah, great point.
Okay, I think that wraps it up. We will be posting this recording on the autocall.com site in the dealer section. And I will also get out a copy of the presentation to everyone following this sometime today. Thank you.
Thank you, everyone.
Thank you, Roger.